Okay, let's start. The topic for today, we have only two topics today. It's inheritance and generics. Have you all done a bit of programming using inheritance? Yes, if you have used an object-oriented language, you will probably have used inheritance. Have you also implemented your own generic classes? Good, then it will be straightforward, this topic. Anyway, in the second lecture, we talked about implementing classes, and I said that the object-oriented program consists of a set of class definitions. A class usually consists of a number of fields, methods, and constructors. And then I gave this example of a simple class and stack for integers. We have a set of fields that represents the data we are associating with a stack. We have a constructor that is used to construct a new stack, and we have a number of methods to manipulate the stack. So in general, you are creating a stack, then you will get one instance described by this class here, and then you are manipulating it, you are adding integers to it, and you are removing integers to it. And each stack has their own set of arrays, and we are also keeping track of what is the current top element in this array. So this is a stack, this is an ordinary class. Today we will take a look at two techniques, basically to extending classes in two different directions. Inheritance can be considered as we are creating a new class by adding new fields and methods to an old class. So rather than creating a class from scratch, we take an old class as our starting point and we add a few properties to it. Generics can be considered as also an extension in the way that rather than having a list that only works for integer, we are creating a more generic list that works for all types of data. And then when we are creating a new instance of this class, this list class for example, we are saying that this particular list should be for integers, but this one should be for strings and whatever. So a class with type parameters, we will implement something that looks like this, but then when we are using it, we are instantiating it and saying that this list should be for integers or this one for strings or doubles or whatever. So these are the two topics for today. I will spend most of the time on inheritance and I will spend much less time on generics. Generics is just, how would I say, implementation issue. Inheritance. I said that when we are designing an object-oriented system, the first thing to do is to identify which parts we should use in this system. What was the name of this process? Dividing the program into smaller and smaller parts. No, encapsulation was something different. Modularization was it. In the end, we have hopefully found a set of classes that, if we're implementing these guys, we think the system will work. And a class, as I said, also describes or models an abstraction of a real-world entity. What this abstraction, what was it? I gave an example. Well, an ordinary real-world entity like a student contains an enormous amount of properties. However, in our system, we are only focusing on a few certain properties that are relevant in a certain context. A student's height is maybe not important, but their grades are probably important. So this process of selecting a few entities that we think are relevant out of all possible properties is called abstraction. So anyway, in the end we have come up with a class, person. We are describing it by a number of fields, properties, and we have also behavior, things we can do with it. However, when you are modeling your system, you will often come up in a situation where you have person, employee, student, teacher, and customer. They all look very much the same. They all have a name, maybe an address and Swedish ID number and things like this. When you're in this situation, you have a number of entities that looks very much the same, and you would expect that their implementation would also be very similar, then you should start to look at inheritance. So, inheritance is a fundamental object-oriented technique for organizing and creating groups of classes that have many properties in common. You will see in the next assignment that you should handle vehicles on a ferry. We have lorries, buses, cars. Well, they form a group of inheritance. They all have many properties in common. So when you are in this situation, you should start to think about inheritance. Can you see this one? I am using a black background here in order for actually the video should look better, but it turns out that some of my figures have a black text. Can you see it? Okay, we have here a system of animals. It is typical when it comes to flowers and vegetables and animals that we are grouping them into different families. They are all animals, but then we are dividing the animals into mammals, reptiles, and birds, and the mammals are further divided into cat, rodents, and deer, and things like this. Have you seen this system before? Do you know who invented it? A Swede called Carl von Linné is the guy, and it's the one we have named our university after. He was the first one who started to divide similar groups into families and consider them as similar. Do you know what a lynx is? Lynx.
White cat.
Do you know it or do you guess it?
No, I don't know.
Okay, yeah. Anyway, even if lynx is a rather lodjur in Swedish, is it? Just by looking at its position here, you actually know a lot about it. You will see that it belongs to the group of cats, and it is on the same level as a tiger and lion. If you saw a lynx, you would probably recognize it as one belonging to this one. They have many things in common. So organizing things like this is a classical way of understanding complex system, and we will form this type of hierarchies. When we are using inheritance, if we are using inheritance on a lot of classes, they will start to form hierarchies like this one. How do you recognize when inheritance should be used? Well, there is something called the is-a test. It's very primitive, but it's very efficient. If you have two entities and you could put an is-a in between them and it works, then you should start to consider inheritance. A bird is an animal, a cat is a mammal, a student is a person, an apple pie is a pie, a text window. If you have this relationship between the entities that you are about to implement, then in most cases inheritance is a good idea. In general, A is a B, then you should construct A by inheriting from B. This one is one of these guys, so we take this one as our starting point and maybe add a few more properties. A tiger is a cat, so we start with a cat and then we are saying, okay, what is special for a tiger, and we add a few more properties for this one. So the is-a test is very simple, and it's also the best one. You should always apply this one when you're thinking about using inheritance. If it doesn't sound good to you, then you should reconsider this approach. Once again, a figure that is black. We have up here a shape. This is our root of our hierarchy. Everything is a shape, and we have a rectangle, a triangle, and a circle down here. A circle is a shape, a triangle is a shape, a rectangle is a shape. We would like, initially we are interested in graphical objects, and we thought that we should have a rectangle, a triangle, and a circle, and we should implement them. But then we realized that they are pretty much the same. They have many things in common. So rather than implementing one rectangle class, one triangle class, and a circle class, we come up with the idea that they are all shapes. So that means we are inserting here something called an abstract class. It is like a lizard. There is no particular animal which is a lizard. It's just a group of things. And it's the same here. A shape, we don't have any geographical object that is a shape, but they are all shapes. So we put together here things they have in common. They have all an X and Y position. We can move them, that means update this position. We can ask them what is your area, and we could print some information about them. So up here in the abstract class, the root of this tree, we have the abstract class with things that are in common. Then we are constructing a rectangle by inheriting from this one. It will automatically get all these properties, and then we add a few more here. And the same down here. The corresponding code looks something like this. We start by creating an abstract class called shape. It contains the position of the geographical object, where it should be positioned in a window. It has a constructor where we are providing the position. We can move it from an old position to a new position. You can ask it what is your area, and you can ask it print information about yourself. Certain things here are abstract. That means we don't provide an implementation. But we are saying that any shape should be able to answer this question, what is your area? We are also saying here that any shape should also be asked, should have a method called print that prints information about it. So these two methods are abstract, they don't come with any implementation, but they are deciding what we can do with a shape. All shapes will have these two methods, although we haven't implemented them yet. These things are ordinary concrete classes. We can move any object from a certain position, from a current position to a new position, like this. Here I start to create my first concrete object. I'm saying that the class rectangle extends shapes. It means inherits from shape. Then I say that in addition to these things up here, they should also have a double representing their height and a double representing their weight. So I add more properties. These are the base properties that all shapes have, and then I'm adding, saying that a rectangle should also have a height and a weight, and my constructor here, to create a new rectangle, it takes a position and a height and a weight. And this call here is that, okay, we start by initializing the rectangle in the same way as a shape. Super points upwards in the hierarchy. So by calling super here, we're saying that the first thing we do when we are creating a new rectangle is that we are initializing it using actually this approach up here. And then we are adding a height and a width also. We are also replacing the abstract methods up here with concrete implementations. In the case of a rectangle, we are computing the area by multiplying the height with the width. And when it comes to printing, we are printing a rectangle with a certain height and a certain width. So we are forming a new class rectangle by taking this one as our starting point. This is things that this is the starting point, and then we are adding a few more things down here. And I'm not showing it here, but a rectangle, a triangle would look exactly the same. In a triangle case, we would also have a height and a width. The only thing that would be different is that we would compute the area slightly different, and we would also print something else here, probably involving the word triangle. Do you understand how I'm creating a new class here by extending this one? So a rectangle is not only these things, they also have these properties up here. If it is abstract up here, we must implement them. When we are saying that the rectangle extends shape, we must implement all the abstract methods up here. So an abstract class is something in between an interface and an ordinary class. It has at least one abstract method, and if it has an abstract method, it must be declared as abstract. Similar to interfaces, you cannot create them. You cannot create a new shape. They are only building blocks to create new classes. I think about them as a lizard. There is no such thing as no specific creature called a lizard, but we can create different lizards starting from a lizard. Did it make sense? Yeah. So this is a typical abstract class, and in the top of the hierarchies we are using abstract classes to help us construct concrete classes later on. If you would take a look at the Java implementation, they have an abstract list class. And then when they're implementing an array list, a linked list, and a vector, they are all inheriting from this abstract list class. Why is it a good idea to have one common class that they are all sharing? Why not copy and paste the code and start from scratch?
You have to change something that is common. You have to change only one.
Yeah, that's one thing. That's one property. We don't have to duplicated code or redundant code. And as you pointed out here, redundancy is something that we try to avoid. When we should fix a bug in one of the parts of the code, we often forget to do the same update in the other one. So after a while, pieces of code that in the beginning was identical start to drift apart and have different properties. Another advantage is that if we have implemented rectangle, triangle, and circle by inheriting from the shape class, we can treat them all as shapes. Up here I'm creating a rectangle, an array of size 3 that can contain shapes. You cannot create concrete shape objects, but you can create arrays that can contain shapes. So they are all shapes in one sense. So I'm creating an array here of shapes, and then in the first position I add a rectangle, a triangle, and a circle like this. So not only are we reusing code from the superclass, we can treat them all also. We can treat them as a superclass because they all have a move method, they all have a print method, and they all have a get area method. So the things they lose in some sense their unique properties here. When we are inserting into the shape, they are all shapes. And when we are manipulating them later on, the only thing we can rely on is the properties specified in the shape class. However, when we are in one iteration here asking one object asking the rectangle to compute its area, it will compute the area in a certain way, and the next one, when we are asking the circle to compute the area, it will compute it in a slightly different way. And I would say that reuse to only save a bit of coding is not the important part here. The important part with inheritance is that we can treat them uniformly like this. We can have different types of employees at the universities, teachers, whatever, IT specialists and things. And in certain aspects, we can treat them all as employees. They have certain common properties in common, so we can put them all into an array of employees and then pick them out and ask what is your salary and what is your duties. It works for all of them. A bit of terminology. Shape is a superclass of rectangle. This is what we are saying. It is a superclass of a rectangle. Rectangle is a subclass or derived from shape. Also, sometimes we look at them as a tree. We say that the shape is the parent and child, and rectangle is a child of the tree. So in different views, we are using different ways. But the one on top of the hierarchy is a superclass, and the one below is a subclass. So when we are designing hierarchies, you should, in your assignment 2, you will handle vehicles. Then, of course, you should have a base class called vehicle. It's an abstract class that points out what they all have in common. And then, in the superclasses, we are, and also, fields and concrete members here represent properties and behavior that are identical in all subclasses. In the shape class, I had the method move, that were moving, updating the coordinates of the geographical object. It was never changed in the subclasses. We are moving one geographical object from one position to another position in exactly the same way, independent of the shapes. So concrete members and fields in the superclasses represent behavior that are identical. Abstract members represent expected behavior of all classes. For example, we should be able to ask each shape, what is your area, get area. It will look different, but they should all be able to handle this question. The subclasses implement their own version of the expected behavior, for example, the get area. But also, they can add specific behavior. A subclass can do more than implementing the abstract classes in the superclass. It can also add new methods. For example, a circle might make sense to have a method called get diameter. It doesn't make any sense in a rectangle and a triangle, but we can add it. It might be useful for a circle. Yeah. In general, when you're designing your hierarchies, if you can identify properties that they all have in common, you should try to lift them up in the hierarchy. If they are identical, the behavior, then you make it a concrete method. If they are similar in some ways, for example, get area, you make it an abstract member. So, why inheritance in the end? Well, of course, code reuse. We avoid implementing the same properties and methods in all classes that have a similar behavior. We are also talking about concept reuse. This is basically the abstract methods. We don't provide a concrete implementation, but we are expecting them to fulfill the same properties. We can ask them for get area, for example, or print themselves. Organizing things. Carl von Linné organized the animals and the plants in a hierarchy, and it made it much easier to understand it. You will see that if you're implementing system and you start to have a hierarchy of objects, it will be much easier for you. You know that, well, all of them are shapes. I know how to handle them. They all belong together and form a family up here. So this group of classes are easy to understand. They behave similarly in a similar way. And as I said also, we can treat different classes in a uniform way. We can add a number of triangles, rectangles, and circles into a list and treat them all as shapes. No matter what their exact type of objects are, we can treat them as a uniform collection of shapes in this case. Extendability should be down here. Once you have a class hierarchy, adding a new entity like a square or ellipse is rather straightforward. You find a place in the hierarchy, you insert it there, and you might add a few more methods or properties. Where should I add a square? Yes?
Down on the rectangle.
As a subclass of the rectangle or as the child of the rectangle. Yes. Yeah. And the key question here is the is-er test. If we are adding this square here, we should be able to say a square is a rectangle. Does it sound okay? Yeah, a square is a special type of a rectangle. And the ellipse? What? Here. An ellipse is a circle. No, it doesn't sound as good. The is-a test is important. It will give you a lot of hints. Basically, we should insert the ellipse here and have the circle beneath it. So sometimes you have to reshuffle things. So when you are about to add the new thing, like a square, all we have to do is to find the position in here, add it down here, and then we are inheriting all these properties, we are inheriting all these properties, and maybe we have to add, update or simplify the get area method or something like this. So once we have a hierarchy, adding a new entity to it is often rather straightforward. So there are a number of reasons why inheritance is a good idea. I would say that this one is my favorite. We can treat them all the same way. No matter whether it's a circle or a shape, I can treat them as an array of shapes without bothering about their identity. This is something that I call a questionable or a bad approach. I have a list class, an embryo of a simple list implementation, and I would like to create a set. A set is a slightly different data structure. We haven't talked about them in detail yet, but they are a data structure that doesn't contain any duplicates. If you try to add the same element twice, it will be ignored. So that's the key property of a set. Okay, I'm lazy, I have a list, and then I would like to create a set. Then I can extend the list, and then all I have to do is to add this property. I'm saying that if it is not already contained, then I add it. I check first, do we have this element? And if we don't have it, then I'm adding it. Otherwise, I'm ignoring it. So basically, I could take a lot of the add and contains and remove from this one. All I have to do is to manipulate the add method a bit, and I have a set. I might be forced to add a few new methods, but many of the things in here could be reused. Still, I think this is a problematic case, because a set is not a list. For me, I'm familiar with data structure, it's like saying a triangle is a rectangle. It doesn't sound good at all. A set is not a special case of a list. They are something with slightly different properties. And although we could probably save a bit of time and a bit of coding by taking this approach, it is not recommended. In the end, if you start to use inheritance only to save yourself a bit of coding, then your classes will be related in strange ways, and it will be difficult to understand. So only use inheritance when the is-a test works. Otherwise, your code will be hard to understand. If you start to use a student to implement a cat, things will be very confusing in the end. So don't use inheritance just only to simplify or speed up your implementation. The is-a test is a key issue here. If you're not having this one, your code will be difficult to understand and maintain, and it will be error in the long run. Inheritance in Java. I have shown one example so far. A class can only be derived or inherit from a single superclass. You can only inherit from one and only one class. You cannot say, I'm inheriting from this one and from this one. What should be the problem with inheriting from two classes?
If there were the same public, the same method,
yeah.
Is it confusing
yeah.
which of them is in?
If I were inheriting from two classes and they both implemented the same methods, for example, which one is used in the subclass? For example, the C++, they are allowing multiple inheritance, and then they make use of the ordering. It takes the method in the first one in the list of classes. But Java, is a newer language than, for example, C++. They were very much influenced by C++ when they designed Java, but they decided to remove certain things that were complicated, that they can do without, but they were complicated. And multiple inheritance was one of these things. Later on, C# was introduced, and they followed the ideas of Java. They also allow only to inherit from one class. Multiple inheritance has certain advantages, but it complicates more than what we benefit from it. So, however, you can implement multiple interfaces. So assume that I have a class A, and I have two interfaces, I1 and I2. Then I can create one class B that extends A and implements two interfaces at the same time. So this is a valid construct, but extends A, comma B here would not work. You can only inherit code from one. Yes, a question?
What would happen if class I1 and I2 have a function with the same name?
Well, then you mean I have two interfaces with the same name?
No, the two interface has a function with
Yeah.
the same name.
Then it's not a problem. Assume that the interface have a method add and the other interface has a method add. Then with one method we can implement them both.
You can create two implementations?
No,
Okay.
no, I can only create one. But if the signatures for a method in here and a signature for a method here turns out to be identical, then I only need one class to fulfill this criteria. Of course, the description of this class might be something completely different than this one, then I'm in trouble. But from a coding point of view, if it's the same signature up here and here, one method can do the work.
We can specify, for example, I1 dot add
No,
I1.
no,
There won't be one.
it will not work. A subclass inherits all the characteristics of a superclass. We have a superclass up here and we are creating a subclass down here. It inherits all the properties. So everything we can do with a superclass, we can also do with a subclass. The subclass can do all the things in the superclass and maybe a few more things. So when we are having a variable called, we have here a hierarchy A for B, C. I have pointed it up in here. I will often use this as an example. We have a small class hierarchy with A on top, and then we have further down B and C. In this case, everything an A object can do can also be done with a B object, but not vice versa. That means if I have a variable of type A, I can assign it a B object. You can think of it that this statement here says that this variable will reference something that has these properties. It should have the A properties. Whatever fulfills the A properties can be assigned to this variable. So we can assign it an A, but also a B and a C. A B and a C can do everything that we expect from an A. That means it will work as a replacement for an A. However, in this case, I'm trying to assign an object of type A to a variable B, but a B in general can do all the things of A and a bit more. It can usually have a few more methods and properties. So this will not work. Did you understand this one? Think of the type, the A here as saying that it specifies what we should be able to do with this type of object stored in this variable. And everything an A can do can also be handled by a B, but not vice versa. When we have a B variable, we can assign it a B object and a C object, but this one cannot do all the things that the B can. The B can have more methods and more properties. Straight assignments work like this. Cast, I am assigning a C to an A, it works. I am converting the A to a B, it will also work, because a C can do all the things of a B here. But I have to since if I were just writing BB equals A down here, it will have a type error because it would look like I'm assigning this one to this one. But what we are doing here is I know that this variable here holds a reference to this one, so I'm actually overriding it, the previous law saying. Yeah.
When you are casting from A to B, the methods that are implemented in B or the properties that A doesn't have them, they're going to be default values.
Good.
If we can say that A is shape and B is triangle, no?
A is shape and B is triangle. Yeah, okay.
And if you cast from shape to triangle, like for example, maybe some properties that triangle has that shape doesn't have them, they will be like default value, no?
No. If I had A up here and I was creating a shape, and I tried to assign the shape to a triangle, it will be a runtime error. Because it is not that they do some default properties. It will, at runtime, when you try to do this assignment, it will discover that this will not work. So you will, I think I have it down here, you will have an error at runtime. If you do this one, you will have a compilation error, but if you are using a downcast, as I said also for the primitive types, downcasting is always a bit dangerous. Something might go wrong. And it's the same here. If you try to squeeze in a shape in a triangle, it will not work. Quite often we have a long list of shapes, and we are picking them out, and then we decide that all the triangles should have a new color, red. Then we are picking them out from the array, and we must be able to ask them, well, are you a triangle? When we are inserting them into the shape array, they are in some way losing their identity. They are old shapes. And in many cases, it's okay. We can treat them as shapes. But sometimes we would like to ask them when we are picking them out, are you a shape or a rectangle or whatever? What is your identity? Then they have, come up with an operator called instance of. V instance of C returns true if the object referenced by V is of class C or a subclass of C. So assume here that I'm assigning an A variable a C object, then I can ask this one, are you an instance of C? It will be true. So this is the approach you will use. You're picking out your elements from the shape array, and then you're asking it, are you a triangle? And if it turns out to be yes, we can give all the triangles the color yellow or something like this. So the instance of operator is the one that we are using to, when we have many different objects of a certain belonging to a certain family, we can ask them, are you a lizard or a snake or what are you? So instance of can be used to check a given object. Do you belong to this one? Do you have the same properties as C? If you're asking this one, you have a variable A here. You have assigned it something, we don't know what it is. But you are asking, do you have all the properties of an A? It will always be true. You cannot assign something to this one that don't have this property. So in Eclipse you will see a warning saying that yes, it will work, but it's a nonsense. It will always give the answer true. Super, I used it earlier on. First of all, in my example with a shape, I introduced a new keyword, protected. What was the name of this type of keywords? They were called? What?
Private and public.
Yeah, they belong to the group of what?
The child classes could.
Yeah, but I'm just wondering, they are something called access modifiers. they are giving privileges, what we can do with it. We have used private and protected earlier on, private and public earlier on. Now we have a new one called protected here. When something is protected, it is like private when you're using it from the outside, but it means that classes inheriting from this one can access them. They are available for things in the hierarchy. From below in the hierarchy, they can access this one. So I have a class person here. I'm saying that each person should have a name and an age. And then I'm creating a class student that extends person here. I'm saying that the student should also have an ID. Then in the constructor here, I can take a name, an age, and a student ID. I can assign this one up here. So down here, I am assigning this field down here. I'm accessing this field up there. So this one can reach this one since they are protected. If you should have used private here and tried to write this piece of code, the compiler will complain. It will say that you have no access to this one. It's still private. So protected means can be used by subclasses in the class hierarchy. So if in a subclass you would like to manipulate the superclass data here, you must make them protected, otherwise you cannot reach them.
You have to put a super.n or not?
No.
Right.
No. Here we come with a super. Super is something that refers to the superclass. Here I have once again the class person, but this time I have added a constructor here that initializes the name and the age. So this one assigns values to these two fields up here. In the student that extends person, I can reuse this initialization. So this call here says that I take the name and the age and I do exactly the same initialization as the superclass person here. And in addition to this, I take the third argument here and assign it to my field down here. So super, when it's used like this, refers to a constructor in the superclass having the same parameters as this one. A string and an integer in this case. Yeah. There are certain other rules. For example, the super call must be the first statement in the constructor. If I should have turned the order down here, the compiler would have complained. But it will point out that this one must be first. You start by basically, we can think of a hierarchy as we have different building blocks. One thing in the end of the hierarchy, it has certain properties from up here, others from down here, and so on. But when we are initializing them, we are creating a new C object. Then we start to say, okay, first we construct this part, then we construct this part, and then we are adding a few properties to it down here. So initialization, since we are using this approach, initialization always starts and is first completed in the superclasses.
What is the problem when I get at the first ID, then call the super constructor? What is the problem?
It's a language rule.
Oh.
The Java has defined that if you're using a supercall, it must be first. Yeah, so it's nothing strange. And it is because they want to have this property that I just outlined, that you're first initializing the superclasses and then you're constructing it top-down in some way. Polymorphism. Polymorphism is a Greek word. It comes actually from many forms, it means. We are in general referring to polymorphism that I would say that certain things are uncertain. Most typical, we have a call. We are calling a method M and a variable A. And in general, actually, we don't know which method that is called. We don't know which version of M that is called. I have an example here. Once again, we have this hierarchy that I have behind me, A, B, and C. Assume that all of them has their own version of M. They all have an M method. I have an array here, and I'm adding an A, B, and a C. And then I'm iterating over all the objects, and then I'm calling M. Which method is called?
It depends on the instance of the class.
Yeah.
The object.
It will be that in the first iteration here, we will call this method. In the second iteration, we will call this method. In the third iteration, we will call this method. But in general, when we just look at the call here, the call site, the call expression, if I just give you a call expression, assume that we have a method called add to list. And I have a list L, and I'm adding an integer N. And in here, I'm writing L add N. Which method is called? It can be any method in any class that implements this particular interface. So the point is, in Java, most of our call sites are what we call polymorphic. We cannot just look at a call site here and say, I know that at execution we will jump to this particular code. It depends on what the current object is in this case. So only at runtime can we decide, okay, at runtime I know that it's an array list up here. Then at runtime I can say, okay, I will go to the add method in the array list. But in general, when I look at this piece of code like this, I see a call, I don't know exactly where it will jump. I know that it will be in A or a subclass to A, but I'm not sure which one of them. Of course, I can, in this particular case, I can read the entire code and figure out, as we said earlier, in the first iteration, this one in the second iteration. But in general, when we take a look at the call in Java, we don't know exactly where it will jump. This is typical for object-oriented languages. If you take a language like C, you can always read the method name here and you know exactly it will jump to this particular place. This is called polymorphic call. That means in one execution it might jump in this way, in another execution it might jump somewhere else. Binding. Binding, the process of associating a call site to a concrete target method M. In Java, we have dynamic binding. It means only at runtime can we make sure where to jump. In certain other languages, like C, there is static binding. I can, by study the code, make sure that I know where it jumps. So the binding is, where should we jump from a certain call? To which method should we jump? This is more terminology related to object-oriented languages or programming languages. First of all, a variable has a fixed type and a dynamic type. The fixed type is the declared type. A variable A here, it is declared as uppercase A. That means its static type is always A. It's the declared type. Then we are talking about something called the dynamic type. It is the type of the object that is currently referencing. So in this case, after this line here, the dynamic type of A is A, since we are referencing an A object. Down here, the dynamic type of A we are referencing B will be B. And in a language with static binding, it is actually this type that decides where to jump. Whereas in a language like Java that uses dynamic binding, it is the current value in the variable that decides where to jump. So static binding resolved using the static type of A. Binding takes place at compile time. That means when we are compiling the program, we know already where to jump. This has certain advantages. We can, for example, maybe inline the code. In order to speed up the program, we can say that, well, rather than jump over here and do the piece of execution over here and then return back, we can take the code in here and move it here. It will make the execution slightly faster. Dynamic binding. Resolved using the dynamic type of A. That means binding takes place at runtime. It is only at runtime that we can decide where to jump. So we cannot do any clever things during the compilation, or not. We cannot easily do any clever things during the compilation since we don't know where to jump.
How about static binding? You mean that, for example, there is a method in A class.
Yeah.
So I'm inherited from A and I'm
But,
overridden A.
Yeah.
Okay? Always it is clear that I'm jumping to A class.
Yeah.
So it is a
Wait a bit. In Java, this is not the case. We don't have, in general, we have dynamic binding all the time. But in certain languages like C# and C++, you can use both dynamic and static binding. You can define a method as virtual, which gives it certain properties, and you have other keywords to specify how this binding should take place. But in Java, Java goes for simplicity. They are always using this one. It is slightly more work at runtime because we always have to stop, look at what object do we have, and then decide where to jump. So it takes a bit more time. It's slightly slower, but don't worry about it. I think when Java was introduced, they compared it to C++ at that time. At that time, it was 30% slower. But now it's down to 1% or 2% or something like this. So they have optimized the virtual machine nowadays. So there is no practical difference between C++ and Java when it comes to performance.
So you mean that in Java always we have dynamic binding?
Yeah, unless you have a static method.
Unless we have a static
Yeah,
method.
you can declare a method as static.
Belong to A class.
Yeah, you can insert here a method M that is static. And then you're not calling it on an object, you're calling it on A itself. For example, we have classes called math, absolute value of something. In this case, there is no doubt. It is the method called absolute value in the math class. So here we have no doubt at all. A static method is a static call. Yeah. Anyway, C# and C++ allows both dynamic and static binding, more flexible but also more complex. In general, the rules for inheritance and binding, how it works, is more complex in these two languages. They have more options. But how does it work in Java? I tried here to write down what goes on at the runtime. Assume that we have a call like this and we are about to execute it. What happens is that we are checking what is the value of this variable. Assume that the type of the object is of type X. Then we start by saying, do we have an M method in X? In this case, we call it. So assume I have a variable here and I have assigned it something here, and I'm calling a.m. In our example here, when we are reaching this line of code, we will take a look what is the object stored in this one. If it is a B object, then we will look into the B class and ask, do you have a method M? If yes, then we are executing this one. Otherwise, we search upwards. So these are what I try to say here. At runtime, we take a look what is the object stored in this variable. if it is of a certain type X, if we can find the method M in X, then we are calling this one. Otherwise, we find M in the first superclass where defined. We go upwards in the hierarchy until we find it. And we will always find it. Otherwise, it's not implemented anywhere and the compiler will discover it. So this is what goes on. These two rules are applied every time we make a call in Java, or at least a dynamic call in Java. They stop for a short while, take a look what is the current object, and then checks, do we have a class method named M in this particular class, in this particular object? If then we call it, otherwise upwards in the hierarchy to find it. It takes a tiny bit of time. Here I have an example. We have A, B, and C one more time. A implements 3 methods, B implements 2 of them, and C implements only 1 of them. I'm creating a C object here, and I'm calling C print. We will stop for a while, take a look at this one. What is your current object value? It is a C. Then we go to the C class and see, do you have a method named print? Yes, we have. Then we are calling this one. Down here, we go to the class C and see, do you have a write method? No, I don't have it. I start to search upward. I find it here, and then I'm calling this one. In this case, I start down here. Do you have a skriv? It's Swedish for write. Do you have a skriv method in C? No, we don't have it. We go up here. No, we don't have it. We continue up here. Yes, we find it, and then we are calling this method. So this is what goes on during a call when we are running a Java program. Let's take a break. 10-minute break. Okay? Or any questions? Okay, let's move on. We have used actually a class called object, and I said it was a wild card. You can assign anything to an object. Now we'll try to explain how it works. There is one particular class that is very important. It's called object. It is the base class of all classes. That means we are writing classes like this, but it actually works like this. Everyone is inheriting from the object class. That means properties defined in this class are properties that are shared by all, every class. Whether you like it or not, every time you create a new class, you are getting the properties, object properties, without asking for it. So the object class methods can be used on all types of objects. That means if you take a look at the documentation for the object class, you will see that it contains a method called equals, getClass, toString, and clone, and a few more. They are always around. You can always, whether you have implemented an equals method or not, you can ask one object, are you equal to another object? The default behavior that you are inheriting from object is to this. They are saying that two objects are equal if it's the same object. toString, it will print the name of the class together with some memory number or something like this. But they always have these properties. If you want to change these properties, which is often the case, you have to override this method. That means replace your new class to have certain toString method and a certain equals method. I will show examples of it. But the idea is, and that you always should remember, that certain properties defined in this one are always available. That means I can have a class with no methods, class number. It has a constructor that are assigning this one the value, whatever I'm giving it. It doesn't have any methods, but still I can create a new number object. I can ask it, provide a string description of yourself. I can ask it, give me your class, and then ask the class, what is your name? I can compare them with another one. Is this one equal to this one? This one will be printed. I said that equal by default are not comparing any values. They are comparing, is it the same object? And here we have created one object up here, and here we have created another object down here. So when we are asking, is this one equal to this one, the answer will be not equal. So remember that certain things comes for free in some way. If you, sometimes this comparison makes sense, but sometimes, for example, in this case, I would think that when you're comparing two numbers, you would like to compare their actual values stored in them. Then you have to override the equals method and say, okay, in the number class, equals should work like this, and then you compare this one with the other one's number. Clone, I didn't say this. You can ask any object, create a clone of yourself. It will create a new object of the same type, of course, as the one that we are cloning, and it will copy all the field values. So it will be a new object with a new object identity, but it will have the same field values as the one you are cloning. This one is rather useful when you want to actually have something similar. Comparing objects. First of all, this one also works for objects. You can ask, is this string equal to this string? But they are always using object identity. They are asking, is this the same object as this one? And since they are created at two different points, although they have the same values, they are two different string objects. So this one will say false. This one will also say false. This one is true. We are asking, are you are not the same as this one? Yes, it's true. They are not the same. However, if you apply the equals method, for example, the string class has overridden the equals method. They have given the equals method a new purpose. And when you are comparing two strings using the equals, they will actually compare this value with this value. So in this case, it will be equal. Comparing this one with this one will not be equal. So certain methods, and I would especially say equals and the two-string method, one of the first things you could do when you're implementing a new class is to override them and give them whatever property you like. I think I have an example here. I have a class point. It's a point in the coordinate system x and y. I have a constructor when you can create new points. But here I was not happy with a standard two-string method. I would like that when I'm asking this string for information, it would actually say that it is a point containing x and y. So I'm replacing the method in the object class with a new version of it down here that actually returns a string containing the x and y coordinates. And the same down here. I'm not happy that the default behavior is to assume that I have created 2 points with the same coordinates. I would like them to be equal when I compare them. They have the same coordinates. But the default would be to compare, is it the same object? No, it's not. But here I am overriding the default behavior. I'm saying that 2 points are equal. First of all, the one I'm comparing it with must be a point, otherwise they are not equal. And if it is a point, I say they are equal if they have the same x coordinate and the same y coordinate. So I provide my own definition here of when 2 points are equal, and they are equal if they have the same x and y coordinates. When is it a good thing? Why is equals method important to override? It turns out that this one is frequently used. For example, in a list, there is a method called contains. You're asking the list, do you have a copy of this one? Then they are applying equals on all the objects. So if you have a list of points and you would like to ask, do you have a point with the same coordinates in the list? Then you must override equals in this way. Otherwise, it will not work. Otherwise, it will check, do you have exactly the same object in the list? So a good thing is to start by overriding the two-string method and the equals method. If you think that you will compare them in any case, override these two methods. Two-string method. If you take a point and give it to system out println, you just send it into system out println. Then this one will be called. They know that the two-string method is always available. So this is the one that will be used when you're giving away an object to system out println. And if you want it to look something like this when you're printing a point, then you should override it. Otherwise it will write the default behavior is to write something like this. The name of the class and some memory location. I think it is this one. So at least for me, when I'm printing a lot of things when I'm programming. I do a bit of coding and then I print something. So be able to print the current state of a point makes sense to me because I will do it all the time. So I often start by overriding the default behavior of the two-string method and provide something that I think is useful. And useful for debugging is often to include the field values. They are the state of the object. Override here. This one is an instruction to the compiler. You are writing override like this. It is an instruction to the compiler to verify that we are actually overriding a method. I might have spelled it wrong here. I think I'm overriding the toString method, but I have an uppercase T here. I think I replaced the default behavior, but I'm not, since I'm not writing exactly the correct thing. If I have this override, it means the compiler will check, okay, he is defining a method called string. Do we have such a method in the superclass? So it will point out earlier that you think you are overriding something, but actually you are not. So take it as it is also an instruction to the one who reads the code. When they see override here, they start to think, okay, he is replacing something in the superclass. So when you are actually overriding something, take it as a good idea to point it out explicitly using this approach. It will help you, since the compiler will check it, and it will help the one who's reading your code to point out what you are doing.
So it is not mandatory.
No, it is not mandatory.
Help compilers or
yeah, you make better use of the compiler, and you are informing anyone who reads your code about what you're doing. That was it related to inheritance. Let's move on to generic classes. Generic classes is classes with type parameters. They have an unspecified type that you are deciding whenever you're creating a new object of that type. You're saying that I would like to have a list of strings or a list of integers. But you are programming it using an unknown type, just a type parameter. It was introduced in Java a few years ago now. It was at the same time introduced in C#, roughly at the same time. As I told you earlier on, these two guys are competing. If someone comes up with a technical idea, the other one wants to come up with something similar. You are instantiating a generic class by providing a concrete type. For example, many of the data structures in the Java library, they are generic. Array list, linked list, stack, they are all generic. That means when you are creating an instance of them, you're supposed to say that this particular list should only be for integers or strings. I have an example here. You have done, you probably used it earlier on in your assignments. This is where I'm using a generic class. I'm creating a new array list, but I'm saying that this particular list, this object that I'm creating up here, it should only contain integers. And then I'm adding integers and picking out integers and manipulating it. If, after having created a list that looks like this, I try to insert a string, the compiler will recognize that this one, no, you cannot add a string to this one. It is only for integers. Here we have the raw version. What will Eclipse say if you're creating raw versions? Yeah, they give you a warning. They don't like the raw versions. But you can still ignore the warnings, and you can create an array list, and you can add integers to it. The problem is that when you're picking them out here, they are in some way unknown type. So you must down convert them here. Up here I said that if we were adding a string to the list by mistake, we would get a compiler error saying that you cannot add a string to this list. Down here, if I by mistake added a string to it down here, I would get a runtime error when I try to pick it out and convert it to an integer. And we always prefer to have compile error before runtime error. So the general idea is you should always, when you're using the data structures in the Java library, you should always use the generic version. It's a bit of typing, but don't be lazy. It's worth, it takes you 2 seconds to write it down, this extra work, or 5 seconds. So don't be lazy, always use the generic version, unless, which is rather rare, unless you want to have a list containing different type of objects. It might be that you have a string in the first one, an integer, and a student as the third element. In that case, you must use a raw version. But you should avoid having data structures with a different type of objects, because when you're picking them out, you must remember that at position 72 I had a string, or in position 5 I had an integer. So avoid that if possible. So why generics? Why not use object? Use object means repeated downcast, means type checking at runtime, means error found at runtime. Generic classes means static type checking, errors found at compile time. This one is much better. That means, and also using generic classes is simple. Always try to use them. Implementing generics is actually not that tricky, but in the beginning it's a bit confusing. When you are creating a generic class A here with type parameter t, and we have a method that takes an unknown t as input, you should do something with it. You can only do things that work for all types of objects. You cannot use any list-specific methods down here, because in that case it can only be instantiated to lists. So when you're implementing generic classes, you must in some way do only things that work for all template classes. It takes a bit of practice, and I will not discuss it here, but it is possible to say that the generic parameter should be of a certain type. It can be any type as long as it is an implementation of the list interface. So you can restrict the possible types by saying that it can be any type as long as it fulfills certain properties. And then when you are using it down here, you can use all these properties of this one. But we will not discuss it in this lecture. As an example here, and more importantly as an example that you can download from the Moodle that belongs to this lecture, we have a generic implementation of a list that I earlier on implemented non-generic. Earlier on I have talked about the interface int list that looks like this, and I provided an implementation that only works for integer. This example we are implementing a more general interface, a generic interface that should work for any type t. If you haven't done any, if you haven't created any generic classes, I think the best advice is that you should always start by creating a specific class. You make sure that you know how to do it for integers, and then you take this one as your starting point and you try to make it generic. So once you have a class that fulfills this interface, coming up with another class that fulfills this one is not that difficult. My class, generic array list, that implements this generic interface, it looks like this. And at a quick glance, it looks identical to the integer version. The only thing is that at certain points, I have an array of t's rather than an array of integers. And we are adding a t rather than adding an integer, but many things look the same. One thing that is a bit frustrating in the beginning is that you cannot create arrays of the generic type. If you try to write a new t, it will not work. When you're creating an object, they must always be of a concrete type. So what we are doing here is that we are creating an array of objects and storing it as an array of t. This one works. But in general, add something, it is exactly the same code as we did earlier on. The only difference is this one. We are calling the resize method, and the resize method makes it twice as long. We are creating an object array twice the length, and we are copying all the elements from the old one to the new one, and we start reusing the new one like this. Take a look at this example back home and compare it with the integer version, and you will see that many things are the same. So here I have one example. this was what it looked like when I implemented a contains method. Contains is used to ask a list, do you contain a certain integer in this case? The implementation for integer was that we were iterating over the array, picking out one value at a time, and if we could find this value, then we were happy and returned true. Otherwise, we go through the entire list, we don't find this value, then we are returning false. In the generic case here, everything is the same apart from this one. We are using equals instead. Otherwise, it's exactly the same. So, suggestion. When new to generics, start by implementing a non-generic version and then convert it one method at a time. Once you have done it a few times, you will actually be able to directly write down these ones. But my best advice is to start with a non-generic version and then convert it to a generic one. Two topics were introduced today: inheritance and generics. Java or Sun. No, it shouldn't be. I'm not sure whether it's correct, this one. It used to be Sun that owned the property of Java, but they sold it to Oracle. So it might be that these web addresses are not correct. Anyway, Oracle or Sun have a tutorial on both inheritance and generics. If you don't have any textbook available in Java, take a look at this one. But if you have a textbook in Java, they all present the inheritance and generics. So look at that one instead. We have a number of exercises in assignment 2 that you can handle right now. First of all, we have a set of theoretical Java-related questions. Have you seen them? We have a bunch of 12 questions. What is a virtual machine? Describe it in 3 sentences. It is just, you can Google them, but for all the concepts that we are asking you about is essential in Java or object orientation. So do not only Google and cut and paste, read it at least. And try to understand it, because you should know what a virtual machine is. What is an error in Java and things like this. Anyway, it's a set of questions that I think is important. Short answers are expected. Then we are giving you an abstract class in the first exercise. We are giving you an abstract int collection. We are also giving you an int list interface and an int stack interface. And we would like you to create implementations of these 2 interfaces by using this one. So many things that are required in the interfaces, you can use properties up here to solve the problem. You will not have to re-implement anything from scratch. You take the abstract class as your starting point, you take a look at the interface, and then you come up with a solution for it. Then we have a more complex exercise, the ferry, the one that I talked about earlier on. You should implement something that simulates a ferry that can take different types of vehicles. So there are methods called embark vehicle, but you should be able to add a bus, a car, and a lorry, and passengers, and different things like this. So you will have to form your own vehicle class hierarchy to this one. But we give rather lengthy instructions, but it's slightly more complicated, and if you're not used to inheritance, it will take you a bit of time. And then the first part of exercise 4 is for you to implement the generic queue. You implemented a queue in the previous assignment, didn't you? We just would like you to convert this one to a generic version of it. Have you received feedback from the teaching assistants?
I believe
Not? Okay. My idea was that if you have received feedback, read the feedback and maybe change the queue class, and then you go on and making it generic. Anyway, that's all for today. Do you have any questions related to inheritance and generics? Do you have any questions related to the course in general? Did you all manage to handle the first deadline? Yes? Most of you, more or less. When you're reaching a deadline and we have asked you to handle 12 exercises, you have only handled 10 of them. Still, I would like you to submit it. You will get feedback on what you have done. So don't miss this opportunity. You will fail because you haven't done all the assignment, but you will still get feedback. So you can submit a better version the next time. So my suggestion is that if you have only solved a subset of all exercises, the deadline is coming, submit them in any case. And expect an F if many exercises are missing, but still it's better. Okay, other questions? Well, see you and good luck with your programming. Tomorrow I think we have a lecture as well. See you tomorrow.